is in, convex, vex is outward. We have the upper and lower poles that we're going to break down, and we have a lot of stuff in between that we've got to master and label, because whenever we add contrast, a lot of this is actually going to light up on our exams when we're looking at the kidneys specifically. So kidneys, they measure approximately 4.5 inches long to 2 to 3 inches wide, 1/4 inch thick, and the left kidney is slightly longer and narrower than the right kidney. That's typically universal across all humans.
Which one did you say was the concave and convex?
Concave, caves in, convex, convexes out. So looking at some of these pieces of anatomy, we're going to break all these down individually, but starting at the top, the outermost layer, like the layer of the bean, like if you think of like a bean has a shell around it, like that shell around the bean, that's the renal capsule. Capsule encapsulates the kidney. Cortex is going to be all this soft stuff right underneath the outer shell. This is all cortex. Renal sinus is this area that caves in right here. Also right down here, right down here. There's multiple renal sinuses. I'm tracing my fingers over as we go through this. Renal pyramids are these things that look like little whiskers, renal pyramids. And actually, if you look at it under contrast, they actually look triangular like pyramids. We'll be able to see that on the actual exams. And then we have the renal column, the minor and major calyces. Minor calyces are going to look like these little finger-like projections on the ends here. Major calyx is where it all comes together. And then this area that connects to the ureters is what's called the renal pelvis. Renal pelvis. Now, if we take all this area with the renal papillae, the pelvis, and the blood vessels, that's all going to combine to what we call the hilum area. That sounds very familiar, yes? We talked about hilum before. Where at? In the lungs. In the lungs. Take it way back. This whole area that I'm drawing my hand over right here is the hilum of the kidney. Hilum of the kidney.
You said the renal papilla and the renal pelvis?
Renal papillae, renal pelvis, and these blood vessels, the artery and veins that connect into the kidney. So we have a renal vein and a renal artery that's going to filter all that waste product into the kidney. So people don't realize that your waste, like whenever you're drinking water or soda or whatever, that's filtering into your bloodstream first. It comes from the bloodstream and then goes into the kidney, goes through all this stuff, which we're going to break down, and then it's going to filter into your ureter. So you're not like making urine through your stomach or your intestines or anything like that. That's being absorbed into your bloodstream, and from the bloodstream it filters into the kidneys, and the kidneys filter out the waste. Did y'all know that? Or do you think this, all your pee came from your intestines? I mean, it all goes down the same hole, right? I mean, you drink and you swallow fluid, you swallow food, solid and liquid. All right. So the kidneys, where are they located? Now it's called the retroperitoneal area. That's way back to first semester as well. That's our posterior abdominal wall. So if you were to cut someone in half in a sagittal view, the kidneys would line up with the spine. That's going to be more in the posterior area, retroperitoneal specifically. The superior aspect is more posterior than the inferior. So the kidneys kind of tilt backwards is what that's saying. See how it's kind of slanted, tilting back? And they extend from approximately T12 to L3. And they'll typically be higher in someone with a hypersthenic habitus. Y'all know what hypersthenic means? A very obese person, so the kidneys are going to be higher. And lower in persons with an asthenic habitus. They're falling out in very skinny people, just like the intestines do. And big bold letters there, that's come up as a question. The right kidney is typically always lower than the left in almost every human being. Right kidney slightly lower than the left. And we'll be breaking all this down as we go further. The ureters, the rectum, the prostate, all that stuff. We're going to talk more about that. Huh?
Yeah.
Yeah.
No, because people always get mad and say, I hope your prostate falls out. So I figured it's
Hope your prostate falls out.
That's a hateful thing to say.
That's kind of scary.
Is the right kidney lower than the left because of the heart? Oh.
No, not the heart. His heart's on the left side. I had to think about it for a second. Yeah. Liver's all right here.
Yeah, I know, but I'm saying like on the left side.
So this is the last slide we'll do today, guys, because I do have to run to this meeting. But let's break down these parts we just talked about and define them. Renal capsule, once again, outer covering. We just talked about that. We have the renal cortex. That's going to be the outer layer of renal tissue. That's where like our renal corpuscles are. If you don't know what a corpuscle is, we'll talk all about that next week. That's the microscopic element of the kidney. Renal medulla, that's the inner layer of the renal tissue. Renal medulla. And that's what composes these pyramids, by the way. Renal medulla / 8 to 18 renal pyramids. The renal columns are going to be the extensions of the cortex between the pyramids. And by the way, see how they're actually triangular? That's how they're going to look whenever, if you were ever to cut a kidney open, or if you look at it on an x-ray, they do look like little triangles like that. Yes.
What is this 8 to 18 renal pyramids? The number, the
So you see
8 to
these
18.
triangles?
Yes, sir.
There's so these triangles break into more triangles. You don't really see it here because it's more microscopic, but it's saying there's 8 to 18 pyramids within these triangles. Each one's a renal medulla, and the pyramids are found within the medulla.
So some people, it differs from
It
kidney to
varies.
kidney.
It varies.
Some might have 8, some might have 18.
And it doesn't really change anything, it's just different between everybody. And finally, the nephron, that's the essential microscopic component of the kidney. So if you were to put all this under a microscope where you see all these little veins and arteries, you're going to see that actual nephron, and that's what does all the work of that filtering as you get the waste product from the blood. And we're going to break down that nephron next Tuesday. We're actually going to look at the microscopic element and learn how to label what a nephron looks like. Typically, that's usually the part people have the most trouble with this chapter, but we'll take our time and break it down a little further on Tuesday.
It's the microscopic.
Yes. Sounds like a neuron, right? Neurons in the brain. We're talking about the nephrons, it's in the kidneys.
Microscopic. The whole purpose is for us to see things, right?
We gotta know how it works, though. We gotta know why it does what it does. So guys, we'll end there today.